In this section, we want to start discussing rational expressions and how we can simplify them. But before we get into that, we need to establish what we mean by a rational expression. A rational expression is a fraction that has a polynomial expression in the numerator and a polynomial expression in the denominator. So an example of a rational expression could be something like 3x squared minus 6 over 4x squared plus 2x minus 3. So a polynomial over a polynomial is referred to as a rational expression. And it's important to note that rational expressions are undefined whenever the denominator is equal to 0. So with this expression that we just wrote above, we would have to be aware or indicate somewhere that this rational expression is undefined whenever that denominator is equal to 0, because we can't divide by 0. Moving into example 1, we want to simplify the rational expression negative 18x to the 6th over 8x cubed. We have a monomial in both the numerator and the denominator. So all we need to do in this case is just look for any common factors between the numerator and the denominator and cancel those out. We can go ahead and bring that negative up into the numerator, and notice that what we have is a coefficient times a variable raised to a power divided by a coefficient multiplied by a variable raised to a power. Looking at the coefficients, we can see that 18 and 8 are both divisible by 2. So if we divided those two values both by 2, we would end up with negative 9 in the numerator and positive 4 in the denominator. And then we can reduce the variable component by using properties of exponents. This is the same thing as times x to the 6 minus 3 power, or what we would end up with would be negative 9 x to the 3rd over 4. When we move into example 2, with that work that we just did in mind, a very common thing that people like to do, or can accidentally do here, is see something like in example 2, we have a 20 in both the numerator and denominator, and people like to try to cancel those out. But we need to just ingrain in our minds that we can't do that, because what we have to do instead is treat this expression in the numerator, 8x minus 20, as one factor, and our expression in the denominator, 20x plus 12, as a single factor, and recognize that we can't cancel through the addition and subtraction. We can only cancel common factors. The way they're written, 8x minus 20 and 20x plus 12 are not common factors, but each of those expressions has a greatest common factor that we can pull out. In the numerator, both 8 and 20 are divisible by 4, so we can factor out a 4, which will leave us with 2x minus 5. In the denominator, we can factor out a 4 as well, which will leave us with 5x plus 6. Now, as a result of factoring out those greatest common factors, we have 2 factors in the numerator, and we have 2 factors in the denominator, and we can again look at canceling out any common factors or reducing any common factors. 2x minus 5 and 5x plus 6 are still not common factors, but 4 and 4 are. Dividing both of those values by 4 will just leave us with 1 in the numerator and denominator. So this expression will reduce to 2x minus 5 all over 5x plus 6. And again, we want to avoid that common mistake where we see a 5 in the numerator and denominator and try to cancel those out. We can't cancel through the addition and subtraction. we still have to think of 2x minus 5 as one factor and 5x plus 6 as one factor. And we can only do these cancellations if those factors are common, have something in common with each other, or in the case of 4 over 4, are identical, and they'll just cancel out and reduce to 1. In example 3, we want to again factor out a greatest common factor the way we started in example 2. We're going to leave the numerator untouched, but in the denominator, we're going to factor out a negative 1. Because the result of doing that will change this expression in the denominator to negative 2 plus x, meaning we've made that variable term in the denominator positive. And then if we just reorder this a little bit, this is the same thing as x minus 2 over negative 1 times x minus 2. So just rearranging that addition step in the denominator. Now we have common factors because we have x minus 2 in both the numerator and denominator. Those two factors are identical, so they'll cancel out or divide out to 1, leaving us with 1 over negative 1, which is the same thing as just negative 1. Our factors will always cancel out to negative 1 in a scenario like this, where we have two expressions that are nearly identical, except that the signs are reversed. In the numerator, we have positive x and minus x. In the denominator, in the numerator, we have minus 2 and we have positive 2 in the denominator. Those two expressions are identical, except that the signs are flipped. So if we recognize that, we can see that that would always reduce to negative 1, or we can factor out that negative 1 to make that variable term positive and just verify for ourselves that we'll end up with those identical factors that will reduce and cancel out.